replacement, and it ain't. You might also want to get another keyword in there. If you can get the word shim in there, that would help a lot. You're not doing a generic update of 6040. You're updating it for shim headers. All right. I think I need to go ahead and try to get started here. A minute. All right. So. There we go. Okay, all right. Let's see if we can get pushes. Okay, let's go ahead and get started. So this is the Transport Area Working Group, Tsvwg. This is the first of 2 meetings in Seoul. We're going to have 2 hours today and an hour tomorrow morning. I see Gory on Meet Echo, and I'm David Black. We're your co-chairs of this circus. I've lost count of how many rings, however, so. This is the note well. Please read it. It applies to you. Anything you say or contribute to the IETF discussions in any way is covered by this. Okay, I need some volunteers. I need a couple people to take notes. Please, this is not as hard as it seems. I need people just to record key points of discussion and key conclusions. And I'm happy to go slow or stop discussion to capture key points. So, can I get someone? Can I get a couple people volunteer to take notes? Gee, lunch must have been good. All right, we may do this military style. Randy, since you're not speaking until tomorrow, can you try to capture notes today? All right, that was one. And I'm looking back there at Michael Wetzel. I think you're very interested in at least one of these discussions, right? Okay, thank you. And let me go take some notes myself here. And I need a Jabber person. It says Jabber scribe, but the job really is relayed, just to monitor the Jabber room and relay things from there. Is anybody in Jabber in the meeting? I'm looking around. Martin did this last time. I don't see him immediately. He may have had the good sense to be elsewhere. Who's in the Jabber room? Yeah, I know that. Yeah, but I need somebody to relay things into the Jabber room. And let us know when Gory has a question. I tagged Spencer, except that he's got some more important things to do.
Thank you.
Okay, and you are? I'm sorry, Tim who? Cool, thank you.
And if I may just say this for future IETFs,
The Meet Echo client includes all the Jabber you need to do that. So if your laptop or your corporate policies or whatever don't allow you to have a Jabber client, there's one running on the Meet Echo page during the meeting, and just turn the sound off. It works great.
And you can go inject things into Jabber from there?
Absolutely.
Cool. You know, I ran the Meet Echo client yesterday for a session where couldn't make it back here, and it worked well. The Meet Echo guys, thank you, and girls. Okay, please make sure to add Tsvwg to any ID submitted and add it in the right place. It's draft your name Tsvwg da da da. You'll see we had one draft that accidentally got misnamed and is now your chairs couldn't find it because of this. So add any IDs to be put in the right place. I think there may be progress on a third working group chair or secretary. Please talk to the ADs. Spencer is here. I presume Miria is Miria here, or is Miria elsewhere, Spencer?
I believe she is in a side meeting right now. I will not be surprised if she pops in quickly, but I left the meeting early.
Okay, cool. Okay. Anyhow, if you're interested in being in being a third working group chair or volunteering as an ongoing secretary, please talk to the ADs, and that was Spencer, who you can't miss. All right. Okay, ongoing, and we're going to hit this later in the session. Document quality relies on reviews. We do need people to review documents, and the request is review documents here and pick a document you're interested in from the working group. If there's a document you care about that you'd like to see move forward, please review other people's documents, because documents you care about will need reviews, and if you help out, other people will be more likely to help out. Please, thank you. Okay, we get to accomplishments and status. We have no RFCs published since '96, but we've been busy. There are now a total of 5 internet drafts in this working group in the RFC editor queue, 3 of which have made it there since last time. The DiffServ and WebRTC QoS draft is now in the RFC editor queue. The details draft has been there for a while. GRE and UDP is new to the RFC editor queue. Circuit breakers has been there for a little while, and UDP usage guidelines update is now in the queue. Getting those 3 drafts done, DiffServ and WebRTC, GRE and UDP usage guidelines are major accomplishments. Can we get a round of applause for the long-suffering authors and editors of those docs? Okay, thank you. We have one ID and post ID of last call processing, DiffServ interconnection or DiffServ intercon. That's going to telechat after Sol. I believe December 1 is the first telechat after Sol. We have one ID that is completed working group last call. Congestion feedback. It got 1 review during working group last call from yours truly. We need at least 2 more. Bob, I think I talked to you. Bob Briscoe is going to do one of them. Can I get somebody else to volunteer to do a review of the tunnel congestion feedback draft, please? Jake Holland, thank you. And a fresh set of eyes would be wonderful. Great. Okay. We have 2 IDs are likely to work group last call soon. The SCTP ID to chunk draft, which we'll talk about tomorrow, and the DiffServ to 802 mapping, which we'll get a status update. That draft's done. It's been stable for a while. There are 5 additional active working group internet drafts. Lower effort per behavior for DiffServ. The initial version has now been posted. This is the draft where we had the problem with the name. It is now posted under the correct name and should show up on our working group page. ECN and CAP guidelines, ECN for tunnels that use shim headers, SCTP NAT support, and SCTP errata and issues. All the SCTP drafts are tomorrow. Okay. We always stick this slide in. Related drafts you might want to read. There's a draft describing how congestion control works in latest generations of mobile networks. That's 4G and 5G mobile. There's a tunnels architecture draft over in int area that covers everything you ever wanted to know about tunnels. MTU and fragmentation considerations are of strong interest here. But there's a whole pile of other stuff this draft covers over in int area. And the routing area has general draft that has correspondingly broad scope on encapsulations with particular application to UDP encapsulation. Bob, you should go to the mic to ask questions, but I'll relay it here. Bob asked sort of, what's the future of the Ingemar Johansson's 4G, 5G draft? I don't know. It'd make a lot of sense to publish that as informational, but I haven't been asked. I'm not the author. It's just right now it's useful information. Okay. TCWG agenda. We need to do agenda bashing. Today is accomplishments and status, which we've mostly been through, milestones review, drafts, and then we'll go to Wednesday's agenda. So let me go ahead and first do a couple of things. All right, first things first. I got a little sign here that says there's a pink box up here. Speakers should really stand in the pink box if you want a remote view, or to make the point, here's the secretariat. Okay. I'm gonna keep using that slide until it gets really, really old. Okay, so rest of today's agenda. I'm going to do the draft status updates here in a minute. We're going to do less effort per hop behavior. We then have half an hour across 3 L4S drafts. I think there actually are 3 presentations here. We then have the ECN experimentation draft, which is going to be in some ways a follow-on to L4S, but it's broader. It covers L4S and 2 other experiments. It's really about areas experimentation. There's a couple of drafts here on guidelines for adding congestion notification to protocols encapsulate IP. This is going to be just a quick status update. Bob says he's got not much has changed, no slides. And then we have down at the end, we have a couple of quick 5-minute introductions to some new drafts on congestion control. These are going to be discussed in ICCRG, which comes immediately after this session, but we figured give the authors at least each 5 minutes to explain what the problem is that they're solving and how they're going about solving it. Come back Wednesday. We have 4 SCTP drafts, and then close with a couple of individual drafts. Transfer options for UDP. I get to try to channel Joe Touch. This is always fun. And forward error correction. Anybody want to bash or comment on the agenda? Going once, going twice. Consider it bashed. All right, let me quick do the status updates. So UDP usage guidelines. That one's now in the RFC editor queue. Done. Diff server intercon, we just did. That one's going to be on ISG telechat after Sol. Tunnel congestion feedback we've just covered. Reviews the list in about next couple of weeks, please, so we can declare victory and figure out what the authors need to revise it. And diff server 802.11 mapping. That should go to working group last call fairly quickly after this meeting. All right, back to these slides. Okay, milestone reviews. So tunnel congestion feedback's gotten slightly delayed. We're going to submit this in December after the rounds of reviews. SCTP new data chunk you'll hear tomorrow. This one's basically done. Ready for last call. We hope to submit this one in January. SCTP NAT support. We'll talk about that tomorrow. I'm going to guess April. ECN for IP and IP tunnels, probably April is a guess as a submission date. Bob, you got any better ideas? Yeah. We're gonna WG last call diff server 802.11 soon. Hope to submit that in January. A guess on lower effort per behavior is 1 more meeting cycle, so May is after Chicago. Bob, any guess on submission date on when we might want to send along ECN for tunnels? Is that likely to be paired with sorry, ECN for tunnels use shim header. Is that likely to be paired with this ECN for IP and I? Whoops, sorry.
I wasn't following actually. My previous answer assumed you were talking about that one.
Okay.
The ECN NCAP one, it's been sitting there, it can go to work with classical now. I mean,
Okay.
the whole liaison's been done, everything.
Yeah. Do you want to send both drafts to WGLC at the same time?
That one can go first because the other one refers to it.
Which one should go first?
The NCAP guidelines.
The NCAP guidelines. Okay.
The other one's a proposed standard. So it's
All right. So for ECN for shim tunnels, let's figure on. I'm going to mark that as June. That way, I've got a little more time to get them done. Okay. And
you'll expect that this one goes sooner because if we're going to tell the 3GPP to refer to it.
I'll move it up to April. It needs to get in line. We've got a few things. We've got a few things a little more urgent that are ahead of it. But yes. All right. And is Maxime here for the 4960 errata draft? What's a guess for when that draft's going to be content complete? Wild guess. Okay, so it sounds like we need at least 2 meeting cycles on that one, and I'll figure it out. SCTP. I suspect that August was 2 meeting cycles. All right. So a quick review of the agenda, and let me see if I can get okay. ID's following work group adoption. ECN experimentation draft, which is mine. When I speak to that, Spencer's going to be here to run process on it. All 3 L4S drafts asking to be adopted here. If anybody's curious about the other 2 ECN experiments, the what's called alternative feedback and the generalized ECN, which is ECN for control packets and things like that, those are TCPM drafts, and they'll be handled in the TCPM working group. Okay, this is just a quick re-review of the agenda. And so for today, it's going to be the lower effort PHB, item 3, the L4S drafts, ECM related drafts, and then 2 congestion control proposals to round out the meeting. And then on Wednesday, we've got SCTP drafts and 2 individual drafts. Any questions? All right. That one's down. Let me go find the presentation deck I want next. Hang on a minute. What I want to do here is, let's just grab the slides off of that. Okay. I could stand at the mic. In fact, I probably should. Having put up that pink box slide, I probably should do that. Okay. Okay, so having just stood up and stood in the pink box, I'm now channeling Roland Bless. Roland can't be here, but he's taken the lead on doing something better about some of the situations we've discovered around the lower effort per hop behavior. This is DiffServe for what does less than best effort service look like. Okay, so it's been around for a while. It's been documented in RFC 3662. It's for background traffic, backups, web crawlers, things where you just like something to get done. It's also been called scavenger class. The bandwidth isn't going to get used for anything else. Might as well do something useful with it. And in fact, a scavenger name looks like it came from the internet too. The 3662 was the initial attempt at that. In 2020 hindsight, we, and I was involved in DiffServe at the time, didn't quite get everything right. So first thing is we picked the wrong code point. Currently, 3662, and really it's 4594 that did this, pretty much specify class selector 1. And that's not the right code point. It's led to some confusion. It invites priority inversion. It's just unclear whether it's actually going to be treated better or worse than best effort service. I had to write this up at great length in the DART RFC warning that if you try to use this, you will either get less than best effort service, or you might get better than best effort service, or you might get none of the above. It's just not real clear. And we've now hit this issue in the RTC RibQS draft, the DiffServ Intercon draft, and since I didn't work with Roland on these slides, I can add a few more things. We also hit a piece of it in the DiffServ for Wi-Fi draft, where there was some unclear language around this PHB that led Tim Szigeti, whose last name I've just butchered, I'm sure, to think this might have been a better than best effort service when it surely is not. So we've got some cleanup to do. Discussion. All right. The ID suggests a dedicated code point and is pulling one out of the standardization space. It's going to have to go standards track. Roland asked standards are experimental. It needs to go standards track. We need a reference to point to for how to do this right. Brian Carter suggested a number of things, all of which look good to me. One is if 3662 is wrong, we should obsolete and replace it. Second is update 4594, especially as the problem we found with the DiffServ for Wi-Fi draft is some bad text in 4594 that does need to be fixed. And he's got a problem where he's going to need to pick up a different piece of IPR boilerplate because he's pulling text from 3662. That one's minor. Any comments or questions on this before I move on? I apologize for doing a monologue here. Obviously, Roland's digging in the right place, or you're all asleep after lunch. Okay, let me get to remarking recommendations. This is stuff that's probably going to be in the draft for later discussion. The option 1 versus option 2 issue actually came up in DiffServ Intercon, and at least in DiffServ Intercon context, that turns out to be a carrier operational practice. We do have drafts, documents, I think 2474 in particular, that recommend that if you see a DiffServ DSCP that you don't recognize, carry it across your network unchanged, even if you treat it as best effort. The response to that from my co-author from Deutsche Telekom on DiffServ Intercon is to observe that alles in Ordnung, which is German for everything in order, is a good operational practice, and carrying DSCPs through the network doesn't support is an invitation for things to go wrong, get confused, et cetera, which is option 2. So we're clearly going to have more discussion about this. This is just a heads up that it's coming. Any questions? And then I'm going to ask for a hum to adopt the draft.
Bob Briscoe, isn't that the whole problem with lesser effort, that if a network doesn't support it, it really doesn't want to be taking in this traffic and promoting it to best effort?
That is a configuration policy at the network ingress. A network ingress could choose to carry us at best effort or could choose to drop it. And I think some interesting words in this ought to be written to make that point. I don't think it's a there's exactly one way to do a decision, but I do think it's a good thing to cover in the draft.
The point is, this traffic is being sent as background traffic, and then you're promoting it to compete with all the other traffic.
And
that's the whole problem of.
And I think that's an operator decision.
Well, yeah, and I think every operator will make the same decision.
I'm not sure.
Andrew McGregor, Google. No, they won't, because we don't do it that way. We do carry it as best effort in the parts of the network and don't support background. That's exactly what we do. For sure, yes.
No, this is general part of the DiffServ architecture, and at interconnect, I think it's an operator decision as to whether to drop whether to try to carry as less than best effort, or whether to bleach and carry as best effort.
Which depends on your nature of your business agreement with who you're peering with.
Right, and if we keep going here, well, we discuss diffs of intercon, which covers the space. Okay, I was going to ask how many people how many people are familiar with the discussion of this draft? The actual latest version has only been posted in the past week was under a bad name. So raise your hand if you're familiar with the topic discussion area of this draft. All right, I only see 3 hands admitting familiarity with the draft, so we're going to have to run this adoption call on the mailing list. I'm not a good idea to take a hum of people who aren't familiar with what the draft's trying to do. Those of us who've worked on DiffServ believe it's important. I'll run the adoption call on the mailing list. Okay, and with that. Let's do. Colin, are these slides okay, or do you want to somehow shove a new and improved deck in here? Or am I confused? And Marcelo's presenting these. That's Marcelo's. Okay, sorry. Everybody's co-opted these. I can't remember who's doing which one. All right. One clicker. And you folks have about 30 minutes. You run a little over, but let's be a little careful on time.
Okay, so this continuing the work that we started in the BOF that we had in Berlin. All right, so what I'm going to present here is the L4S architecture that basically describes the different components that form L4S, give you some very short motivation for the work, and then present the different components that later Bob and Kun will describe. Okay, so what is the motivation for all the L4S effort? Well, basically is to provide a reduced latency service in the internet, right? So basically the idea is, in order to provide low latency, what we're going to try to do is to reduce the queuing latency that affects communications or delay along the paths, right? So the basic reason why, or if you want, the fundamental reason why we still have long queues today in the internet is because the way TCP behaves, we end up with very big sawtooth during congestion avoidance, right? And that actually, in order to obtain high utilization of the network, what you need is to have long buffers in order to be able to use the links efficiently while you're doing this big sawtooth, right? So there are some new congestion control mechanisms, in particular, that have been proven that can exhibit very small sawtooth during congestion avoidance, and you can actually achieve very small queues, and hence reducing the queuing delay across the different links that you have, right? So this type of technologies has already been proven in closed environment. In particular, DCTCP has exhibit very nice behaviors within data centers, and basically the overall goal is to try to obtain the benefits that such schemes provide in the wider across the internet, right? So basically what we're going to do now is, so we're proposing a new architecture that enables the safe deployment of such type of congestion control mechanisms across the internet. And that's basically what we're going to present here, right? So in order to do this, we need to have 3 fundamental building blocks, right? So we need, in one hand, to have the new congestion control with some additional mechanisms to make it safe to deploy in the internet. That would be in the host. Then we need some new AQM mechanism that is able to distinguish what type of transports are using this updated congestion control from the regular traffic in order to preserve the performance of the regular traffic that would be in the network nodes. And then we need a protocol that enables the host to distinguish which are the different types of traffic that it has, right? So as I said, the host part basically includes the scalable congestion control mechanism. We already have some examples of this. They are being currently standardized. In particular, DCTCP is one of them. But in order to make this work across the internet, right, what we need is to include some additional safety measures in order to make this work, right? So I have a detailed list on the draft of the different things that needs to be done, right? But our basic safety mechanisms, like for instance, to fall back to regular congestion control if you detect that the bottleneck that you are encountering does not support L4S architecture, for instance, does not distinguish the different types of traffic. These type of things that are needed to be done in order to safely deploy this, right? In addition for this, we have the congestion control for TCP. This is DCTCP, but you probably want to do this for other type of transports. So that's work that still needs to be done. Right? On the network node, basically what happens is that if you deploy this without further consideration, what will happen is that this new transport because they have smaller sawtooth, what will do is they will try to fill in the queue and oscillate around the queue that it's filled, right? And basically will starve regular TCP. And in addition, they will not actually render the low latency benefits, right? So in order to avoid that, what you will need to do is basically to create two queues, right? One for regular traffic and one for this special traffic, right? And what we need to provide is a different AQM that is able to do that, and that's what we call the dual queue AQM that Kun will present later on. And finally, what we need is a protocol that allows the endpoint to inform the routers, the nodes along the path, which traffic is which, right? So there is one traffic that is this new L4S traffic, and then there is all the rest of the traffic that is legacy traffic, right? So we need somehow some bits to be able to distinguish this, and this is what Bob will present later on. Okay, so now I'm going to wrap up with a
Hey,
very
Marcel, could you have used a smaller font on that slide?
right. Sorry. Right. Sorry for this. So actually, the main message that this slide should provide is that there is a lot of things that have been going on.
Okay.
Right? So this is all the stuff that actually has happened since the Berlin IETF. Right? So this is the different stuff that the different parties involved in this effort has been delivering lately. Right, so as you can see, there is a first part on source code. Then there is the coupled AQM has been implemented for Linux. Right, you have data center TCP that has been completed, and the accurate ECN also the implementation has been completed. There is as you can see, several drafts that have been updated or have been improved in order to continue making progress on this, and there have been a few papers published describing this more in detail, which is probably useful if you want to understand this further. And with this, I'm done.
Okay. Any questions? All right. Next.
Sorry? Right. So both send an email describing all this content to the TCP Prague mailing list with links and TSV as well.
Yeah. So we need.
Yeah. What? No, I just want to give one comment, say like half of the drafts on this list actually go into TCPM, the other half of the draft is here, which makes sense because some of them are TCP specific and some aren't, just so people are not confused where they have to look for the work.
Yeah. The aim is to do, I think, and Mary, tell me if I get this wrong, I believe the primary L4S drafts, which are the three that we're talking about now, will come here. Generalized, accurate ECN is TCPM, and the use of ECN on control packages is TCPM, and the back off changes where you might back off less, might do less, back off by less for ECN than drops is also TCPM.
So that's the big point. Everything that's related to ECN in general, not specific to TCP, goes traditionally into this working group. So the only one who, the only draft that needed some discussion was the dual AQM, but that will be resolved soon and will probably stay in this working group.
And just because Mary and I each are responsible for one of those working groups, I agree.
Okay. So the next topic was about the dual queue, and as you can see in the red, we changed the name. We put TSVWG in front of the AQM, since it's probably going to be in this working group that it will go forward. And it also means that the number changed to 00 before it was 02. Okay. So like Marcelo said, this part is about the yellow part, which is the dual queue. Actually, the implementation of the point 1 there, the purple box, is also part of the dual queue because it has to do the classification into the two queues. So what is updated in the new version which is available? The name, as I said, but in the contents, we added mainly the dual pi square as an alternative of the curvy red, which was in the original draft. So it has a reference to a paper which is out now. It's going to be presented in Connect next month. The pi square paper, which is describing the pi square on a single queue, actually, because it was too complicated to put everything in one paper, so we split it up. But at least it gives you an idea how it works to get the same window size for classic TCP and data center TCP in this case. So in the new draft, you will also find the pseudocoder for the dual pi square. So where it's adding then the two queues part of it. Another topic is that we have now improved the overload code. So, and it's both for pi square and the curvy red. So the pseudocodes are adapted for both. We also, so the main thing is actually that we implemented the time shifted FIFO for both AQM examples, and that we implemented in that queue. You will see there are two options we think are possible to do overload protection additionally for ECN. It's mainly ECN based. It's that we do tail drop on overload, and that's in the pseudocode. So related to overload, actually it's not a dual queue problem, it's more an ECN problem. And there is a problem that there is not really fairness between ECN and drop. There is fairness when the drop probability or the probabilities are low, but near the 100%, and the extreme example is that everybody will understand that if you do 100% drop, it's not the same as doing 100% mark to unresponsive traffic. If you mark 100% unresponsive traffic, everything goes through. If you drop 100% of traffic in general, nothing goes through. So there's a big difference. And that's actually, it's not a dual queue problem we have to solve here. It's an ECN problem that has to be solved anyway, okay, in any ECN capable AQM. Yes, I know. So, but
okay. They are. He sent me new slides 3 minutes before the start of the session. You'll excuse me if I had other things to do at the time.
Yeah, but another ECN problem or related problem is that if your minimum window size is 2 MTUs, ECN traffic becomes unresponsive because it will always send at least 2 packets, even if it's marked for 100%. So that's an additional ECN related topic we have to do. So marking up to 100% is going to bring you in a problem because it will push away all the drop-based traffic, let's say. So with the experiments we did with dual queue and with pi square on a single queue also in the paper, there is an equal window can be guaranteed up to around 25% classic drop. And then it's more or less equivalent, its throughput to 25% of classic marking. So if you go higher than that level, there will be the window for drop-based congestion controls will be lower than 2 MTUs, because if you drop 50% or 100%, it's actually 0. So there is a big difference between throughput then. And it's also similar to around 100% data center TCP marking, because that's also when the window for data center TCP is limited to, and it's not reducing any further than 2 MTUs. Okay. So if we do above 25% non-ECT or the normal drop-based traffic, so if our AQM is giving a number which is bigger than 25% for classic traffic, we should consider doing something else, doing some overload protection. So this 25% at the maximum, let's say, is something you have to, at that point, you have to do something. For instance, in the Pi enhanced draft, I think it's suggested to switch to drop based on 10% classic marking or dropping probability. Yeah, this last statement is the 100% DC-TCP marking probability. It might change for TCP Prague when it becomes responsive to less than 2 MTUs, then 100% marking probability might also mean lower than 2 minimum windows. So that might change a bit. So based on the overload protection itself, the overload protection strategies, we see 2 possible strategies when the probability for the classic ECN becomes bigger than 25%. At 25, it's around 25. It depends a little bit on how the coupling works as well, but that's our details. So the first, which we say here, A, is to limit that drop probability and don't go any further. Don't go higher than the 25%, for instance. And the coupled L4S, which depends on your coupling factor, maybe 100% marking, and stop doing anything else, and then rely on tail drop, because if you don't control the queue size anymore with the AQM, the queue will grow, and at the end it will drop because you get tail drop. So actually you go from a drop or marking based congestion control to a delay based congestion control, because you make the queue bigger, your throughput for congestion controlled traffic will also slow down. And then finally, if it needs to have a too big queue, if it's really unresponsive traffic alone, it will overflow and there will be drop. Okay, so it sacrifices the latency because it allows you to grow queues, and you will see in some experiments I have later that also for the L4S traffic you will grow a queue. But the positive thing is that it avoids drop when you're in the middle between should I start dropping or should I allow a little bit more delay. While in the other strategy, the one which is identified by B there, you can, as an alternative, like in Pi enhanced is described, switch to classic drop for all. Oops, I've been pressing too many buttons here. So what does that mean? If I'm getting a 25% marking probability for the classic and 100% marking probability for L4S, I could decide if it goes higher, I can't go higher than 100%, so I'll just drop with 26% for all traffic. And that will, because L4S traffic is backwards compatible with drop, it will then respond in the same way as classic TCP, and this way we first of all, drop also unresponsive traffic, so we solve the problem, and we still get fairness between all types of traffic. Okay. So that's the second one. Just a note that an AQM is not a flow policer. It means that it's not the normal task for any network device to guarantee that all flows get the same throughput, or that certain flows, or to target a certain flow when it takes most of the throughput. That's a policy, and it might be an optional enhancement. It's not, it shouldn't be the default behavior of any AQM. I think it's important to know. Okay. So we'll show you some, I took some snapshots from the GUI that we showed also in the BOF. And that's with also the code which is in the pseudocode. So the implementation we did is the same as we showed there, and also is in line with what's in the pseudocode. So we use the coupling factor of 2, and the happy coincidence is that if we use 2 and we have the coupling equation, which is a classic probability equals the alpha S probability divided by k, in this case 2, and then the square, that for 100% of alpha S probability divided by 2 is 50, and squared is 25% of classic drop probability. And that's more or less the point where it's all fair still. And higher, we can then switch either to drop for all, or that's case B. And in this case, we're most of the slides will be A. I noted at the bottom which case we are. So A means we don't go higher and we switch to tail drop. Let's say the queues will grow and there is a tail drop for the common queue size. The experiments are on 100 megabits per second link with 7 milliseconds delay. The queue targets for the classic is 20 milliseconds and 5 flows each. And then we insert some UDP traffic. So here you see the GUI that we showed you also on the BOF. You see the blue ones are the data center TCP, the bottom ones are the orange ones are the classic TCP. 5 flows each are here, and this is without unresponsive traffic, and we have like 16% alpha S marking, less than 1% drop for the classic, and a 20 millisecond queue. So that's our baseline. And now if we add unresponsive traffic, and I don't know whether I can have a pointer here.
Yes,
Yep.
push the red button, you get a pointer.
So here and there, we can add unresponsive traffic of both classes. And this 50% normally, but it's 100 megabit link. So it's also 50 megabits of unresponsive UDP traffic is inserted. And what happens, you will see the flows are still fair. So there is only 50 megabit left. And the only change with the previous slide is that this number is lower, half of it, and that the rest of the throughput is divided. And you see that there is 2% drop. There's more drop because there is less capacity. And also the 2% of the unresponsive traffic is dropped here because it's not ECN capable. And you see there is a higher marking probability in line, so that's why they are still at the same. So it's behaving like a normal queue where you also would insert a number of unresponsive traffic. The rest of the traffic obviously needs to use what is left. And here the advantage with the dual queue is that it's still fairly distributed over any flow. What happens if we switch, instead of the classic unresponsive traffic, we mark it as alpha S traffic? Then, of course, there is 0% drop probability because this here is below 25%. There is not that extreme amount of congestion. That means that 100% of these packets are forwarded, but that's because you use ECN. If we would switch on ECN here, it would be the same case. I didn't show it, but Actually, there is no difference between L4S or normal classic ECN in that case. And still the bandwidth is shared. We get approximately the same number of drop and mark probability as a previous slide. So there is not a big difference unless the 2% less drop that you get. That's the only incentive to mark ECN, you could say, for unresponsive traffic. Okay. Of course, they will have 2% less throughput, the other traffic, but you heard, in this case, the other traffic a bit more. Now, if we increase the level of congestion or unresponsive traffic up to 100%, so 100 megabit UDP is inserted, we increase the drop probability for the classic because to 20, around 20%, which is still below the 25 threshold in our case. The marking probability is almost 90% for L4S traffic, so it's a really high level of congestion. You see, it's still fair amongst each other between L4S and classic. And of course, there is now 19 megabit, around 20 megabits available for the other flows to share, and that's what's happening. They still get around 20 megabits divided by 10 is 2 megabits per flow that they still can have. So everything still okay. If we would use ECN in the unresponsive traffic, of course, then we get above the 25%. And then, like we said, the strategy is not to drop any higher. We'll allow the queue to increase and rely on tail drop. And in this case, you can see there is around 4% tail drop. That means that this ECN flow is still dropped with 4%, and there is only 4 megabits or 5 megabits to be shared amongst the other flows. So that's much less. And that's the same what would happen if we would insert classic ECN. So it's not related to dual queue. It's again based on what we do in the AQM in general when we switch to drop, or when a flow uses ECN and we need to define an ECM-based overload protection.
Let me quick check on time management. Bob, how much time do you want? Okay, let's keep going then. I may wind up limiting you to 5 minutes, but we'll see.
What you see is that the 100% marked flow gets around 70 milliseconds delay. That's important because if we further increase to 200 megabits and we don't mark it as ECN traffic, so it's just classic non-ECT traffic, we get up to 52% drop for the non-responsive traffic. There is very little to be shared amongst the other ones, but it's still fair, you see. And we get a tail drop of around 45% of the L4S traffic, and that's because there is still 50% of the other traffic which is 100% marked actually. So there is 100% marking combined with a 50% drop, and that makes it again fair between L4S and non-L4S traffic, where the standard traffic gets around 50% drop as well. So the drop is almost the same. What you see is that here also, because of the tail drop and the side of the queue, there is 70 milliseconds latency for the unresponsive traffic. That's important because in the other case, when I'm doing L4S marked non-responsive traffic of 200 megabit, we get the same numbers, 52 milliseconds, 52% drop probability, and a queue of 70 milliseconds. So there is not really an incentive to use L4S traffic for the unresponsive flow. And the rest is still, again, fairly shared. There is even classic traffic which can still send the same way as there is L4S traffic. Okay. The only difference as well is that because of the time-shifted FIFO behavior, that means that a packet which gets which waits longer than 40 milliseconds in this case, as another L4S packet gets anyway scheduled. So that's why there is never a bigger difference than 40 milliseconds between the two queues. So that's the time-shifted mechanism that you see here. Is there a question?
You're looking for some input, right? On to solve this question, what you should do here, or
is it? I don't know.
Just go on.
I think it's, well, it's this is showing that there is an overload strategy and that it works. So it works in the same way as in a classic single queue environment.
I have a comment, but I'm probably
Yes.
waiting till the end because I
Okay.
want to know what else you want to say.
So there is in this case, we are in case B, when we, instead of stop marking and dropping higher than 25, so we always limit to 25 and go to tail drop. In this case, we continue, but we also make all the traffic higher than 25% drop probability. So in this case, when we get to the 25% classic drop, we drop packets with 25% overall traffic, and that means that you can achieve your target for your AQM at 20 milliseconds, even if we have here, in this case, 100 megabit and 25 megabits unresponsive traffic. The queue size is kept, and we keep on having really low latency for L4S, even with 125 megabits unresponsive traffic. And by just reverting to drop, we also get fair share. So actually, this could be also a good solution if you really want to keep on the traffic in responsive, independent from unresponsive traffic. Okay. This is more or less what I had to say. So the conclusion should be it's working in the same way as a single queue, the dual queue. Okay.
Equivalent. So I would probably always go for option 2. Because first of all, there's no promise if you use ECN that you will never see drop or anything, so it's okay to drop something. And there's a classical trade-off between delay and bandwidth. And I would always decide for low delay here, because basically if you have a reliable transport running on top of it, you can make this trade-off on your own. Because if you drop something, you have to retransmit it, and that means additional delay for you anyway. Or if it's dropped, then you can just not decide you don't need it anymore and you have low delay. So that gives actually the possibility to make the decision at the endpoint correctly as you wanted to have. And the second point is a little bit maybe also on the way you implement this, because I would have expected that you anyway, on the previous slide, I saw a number of, I don't know, 70 milliseconds or even 30 milliseconds, and on the slide before that, on the L4S queue. And I would expect to never, like, I want a low latency service here, so I would expect that you anyway put your maximum queue size at something like 5 or 10 milliseconds, and that if you have a drop tail queue at this limit, then you will never get to 100% marking anyway, right?
Yes, yes. But yeah, it's true. It's a matter of opinion. Well, it depends a little bit what you prefer, whether you want to have delay or you want to avoid drop. Of course, there is always a compromise in the middle possible as well, but we might have to decide maybe one or the other. Yes. Okay.
Bob, and then Jake at the back mic.
Yeah, Bob Briscoe. We weren't actually thinking that the IETF would need to make this decision. We were thinking this would be an operator policy. Yeah.
But I think there is.
Yeah. Okay, but you just think all operators will choose one way?
No, I would really recommend option B, because that leaves a little bit the trade-off to the endpoint and not to the operator. While if you have both options and the operator goes for option 1, then the endpoint doesn't have a trade-off anymore.
You're suggesting we could write that into the draft as a recommendation to operators?
B.
Yeah.
You could. So I would even propose to just remove option A here, but at least I would propose to put a recommendation in there to use option B.
Okay.
Jake Holland, I was curious whether you'd examine the fairness with classic TCP that does not use ECN, that does not respond to ECN.
So what we have here is this classic TCP is non-ECN.
So this is drop-based ECN.
Okay. Then conversely, then, have
question.
you examined
Yes.
the case of
Yes.
classic TCP that does respond to
Yeah.
ECN?
We didn't include it in here, but yes, we did run comparison between classic. So all the combinations we did, yes, and so that's why we made a conclusion up to 25% classic TCP non-ECN with classic TCP ECN based. They're still getting the same window, the same throughput. Above 25%, there is starting to become a major difference near 100%, of
I'm
course.
sorry. So you're saying the top one is just classic with ECN?
No,
Or it's TCP?
The top one here is data center TCP
Okay,
with
that's
ECN, and this one is classic without ECN.
All right.
But we did also other experiments with classic TCP and ECN in combination with all of them.
And that was not substantially different. And, that's
And
why
there
it's
was
not-
no difference. Up to 25%, there was no difference between classic ECN with and without.
Great. Thank you.
Classic traffic
Yeah.
with or without ECN.
Do the slides have a pointer to the results, or can you send a pointer to the full results to the list?
Yes, I could.
Okay.
We have in the paper some of the experiments, but also not all the experiments. Okay.
Alrighty. Okay,
Next
adoption for
slide.
draft. I'll take care. I'll take that one. We're gonna look at adopting LFRS drafts after we survive the ECN experimentation draft. Bob, you've got 5 minutes. See if I can get this right here.
Hi, this one's we left this till last just so it sort of segues into David's talk after it, because this is about the identifier, and David's talk is about the process for allowing the identifier to be an experimental RFC. Yeah, this draft has been around for some time now. That's the title and everything. Same slide as Marcelo put up for the architecture, and just saying, is it the red one? Yep. We are here talking about the identifier, not the classifier, actually just the identifier. So it's the thing that the host sets and the network classifies against. Previously, I've mostly talked about which identifier to use when I've been talking about this draft. And I think ECT1 is now baked in as the likely one. So this presentation is going to be more about what exactly we're defining this identifier, what the normative text is, what we're saying it means. And the ultimate goal of this whole exercise is to get this assigned as an identifier for L4S as an experimental RFC, but that comes more in David's talk about the process, which is coming next. Just some abbreviation pointers there for those that don't remember all the ECN abbreviation stuff. Right, so the musts and shoulds in this draft, and this isn't the actual text, this is paraphrased, so please don't bash this text, bash the text in the draft if you want to. Essentially, it divides into what the sender must do or should do and what the network should or must do. And the sender, an L4S sender must set ECT1, right? An L4S sender should ensure its rate is inversely proportional to the CE marking rate it gets back in feedback. Now that, I've got another slide on because that sounds like a bit specific for a standardizing the meaning of a code point. So I'll explain firstly why it's a should, in that it's not that specific. You can make it roughly, but that'll be on the next slide. And in particular, this draft only defines the absolute minimum requirements for this identifier. So each transport will specifically say, like, how bursty you're allowed to be and things like that, or whatever the particular transport needs are, and to keep the queuing low latency. So this draft doesn't specify what it's like for TCP, what it's like for real-time media transport or anything like that. It just gives an envelope within which everything has to fit. On the network side, this is the only draft that will ever specify that, and it says that it must classify, the network must classify ECT1 as L4S and should classify CE as L4S. The only reason there's a should there is because that's only if it's a stateless network device. If it's something that's got some flow state, it can be a bit cleverer. And say it's a DPI box or something like that that's already looking at flows and it sees a CE in one of its flows that had ECT0 packets, it can say, well, that CE's a classic CE as opposed to another one. You look puzzled.
Yeah, Kulevin. Yeah, because that means if you don't have this state management, which sounds a little bit complicated, that you will see a lot of reordering if you use ECN with classic TCP.
Right. You typically won't see a lot of reordering because I thought I'd covered this before. You won't see a lot of reordering unless you have two bottlenecks, which is quite rare, right? If you do have an ECN bottleneck before another L4S queue, then yes, your CEs from the classic will get put into any CEs from the classic previous bottleneck could go into the L4S queue on this one, so they'll be reordered early rather than late. Right? They will appear earlier than all the other packets in the classic, right? And so, yes, it's just a limitation of the fact we've only got 4 code points, and it would have been nice to have 5 out of 2 bits, but we couldn't do that. Right?
Yeah. Time check. That was 5 minutes.
Oh, okay. Right. I think you know.
I was going to go get a gong sound. I'm going to be nice to Bob.
Okay, thanks. I'll be very quick. Right. So why should it be proportional, inversely proportional? I'm not going to go through this in detail, except to say that essentially what the aim is to get it scalable, and that means an invariant number of control signals every round trip time, and in this case, ECN marks. And the blue lines on these are the number you get comparing, say, a 100 meg cubic with a 100 meg DC-TCP, and then when you go to 800 meg, cubics sawteeth get bigger. They get 8 times bigger that way up, but they get 2 times longer as well because the cube root of 8 is 2. Right? And so you get less and less signals per round trip time, or many more round trip times per signal. You get 500 round trip times per sawtooth, whereas with DC-TCP you get half a round trip time per signal, whatever rate you go, up to infinity. Right? It's just, you get a very high frequency marking. So anyone that thinks cubic is scalable, it's not. You know, right? That's only 100 meg, 800 meg, whatever. Yeah. The sawteeth get very big because it's a compromise between Reno and what it would really need to be scalable. That's why we needed to go for the dual queue. I have to go through this very quickly. The meaning of, essentially what this says is that the meaning of these settings starts with classic ECN is equivalent to drop, and then L4S ECN is equivalent to the square of classic ECN. So it's sort of in a hierarchy. It all relates back to drop originally, right? So we have formalized meanings for all these things, and that formula there gives that meaning, and we don't believe we're going to need to standardize that constant. We think an operator can choose that on their own, but we recommend 2. But we do think you need to standardize that.
At the very least, put some bounds on it so people don't choose ridiculous values.
Okay, we can, yeah, we can try for that. Yep. But the important thing is that too, we do need to standardize the square. We have to choose a number. It's not easy for a standards body to choose a number. You may remember that ATM had to choose 53 for the size of its cells because it was a compromise between two other numbers. And but I think we're fairly clear why that 2 is there, and that's because there was a square root in the original TCP, and we're trying to get rid of that square root. That's why we're having to square things. And this is all about.
I need you to finish up fairly quickly.
Yeah, I'm just going to explain what the whole slide is without explaining it in bullet by bullet. This is all about, even though that square root is only for long-running TCP flows, there's all these other cases where you haven't got long-running TCP flows, but the main principle is do no harm to the lamest TCP. Right. Yeah. Right.
Okay.
And then this is mainly saying we're asking for adoption. Still, please review, comment, all the rest of it. That can all still go on after adoption. And to point out that we are reassigning a scarce IP header code point for a new experiment, so this needs to be considered carefully.
Okay, Brian, and then I'll go talk about careful consideration.
Just to refresh my memory, how many reassignments is that for this code point now in this internet? That's the no, well, because it used to be part of TOS, and then it was for nothing, and then it was for NS, and now it's for nothing again. No, wait, no, NS was the other flag. Never mind. Oh no, it was part of the non.
Strictly, the very last bit of the of the TOS field wasn't assigned.
Right.
Ever. Yeah.
Tell that to the people. Tell that to the people who implemented it.
This field in the IP headers was restructured for diffserv plus ECN.
Yep.
This code point was initially picked up by the nonce, and in my draft we'll talk about we're going to move on from the nonce.
Right.
That's what's happening here.
Good. So there's not a whole lot of nonce deployed, as far as I can tell. Like it might be as many as, if for people who are in Quick, it might be as many as there are still big Indian processors on the planet. Yeah, 21. Yeah, there's 21 nodes that deploy this.
I believe in your study you found 4 that might be
there were 4
on
that might be.
IPv6, none on IPv4, and those 4 may have been.
They were all. That was all. I think that was real because that was one ISP, and it was a bunch of.
Now we're going to talk about 4 as the numerator. What was it?
Thing. Yeah.
That's 4 out of how many thousands?
65,000.
Okay.
So yeah, I think that actually we should probably rerun that study.
Mm-hmm.
We have some people working on code on that right now, and we will report that to this working group. I think that the number is going to be low enough that I can hum yes. But
when you didn't quite finish your sentence when you said 4 in one ISP, therefore you assume they're the nonce?
Oh, then I assume that it's real. I assume that there's like one particular trick that these people are doing and they broke it. So, that might be a thing that you can fix with a phone call.
It could be a middle box in the ISP.
Yeah.
Yeah, I don't think it was any nonce. It was it was all use of the TOS field, and like they rewrote the TOS field. They used the ECN bits and they didn't bleach it at the network border. What's maybe more real is people that use the whole TOS field, including the ECN bits, and bleach it at the network border. So you might see a lot of bleaching. Yeah.
Right. But I mean, that's going to break any use of ECN, L4S, or classic ECN, and there's nothing we can do about that. So, cool. Thanks.
Andrew McGregor, I'd just like to say there is a way to misconfigure some releases of the OS for a certain widely deployed router that will, if you try to do a TOS rewrite, accidentally put random numbers in this field. So it could just be that.
Let me guess. You found
that affects the whole of ECN, not just ECT1. Yeah, it's a random number in the. Yeah, it's all code points. Yeah.
It's biased towards that particular bit.
Okay.
The question that I wanted to ask at the beginning of this rat hole was, do we have any reason to believe that this definition for L4S for the ECT1 code point is any more broken than the brokenness in current ECN, which is going down, thank you, Apple? And I think the answer to that is no.
So as we're talking about it, but I think there's one case where if you have bleaching and you still use data center like TCP congestion control, you would go into the classic TCP queue and take most of the capacity. So I guess you would recommend if you detect bleaching to fall back to classic congestion control as well?
At the moment, we don't get the receiver to look at what comes out of the other end of the network oh yeah, I suppose, no, we do in the fallback at the start. Yes. Yeah, we could do that. Yep. Yep. Yes. There was something someone brought up just then, but I can't remember what it was.
All right, my turn to step into the hot box. Okay, so one of the points on Bob's final slide was careful consideration. Now, we've spent screen in front of the room because it's about to get really interesting here, and that color's the referee's shirt.
How many minutes do you want?
I have 4 slides. I want to get through them in at most 15 minutes. I'll try to get through them in 10. And then we need to be done by quarter after to make sure that we've got 2 5-minute slots for the 2 congestion control drafts.
You're running.
Okay, off and going. Okay, so this draft is motivated because there's 3 areas of proposed EC experimentation. Doing something different from congestion response to CE marks from ECN than you do to drops. The whole L4S experiment, which starts out with ECT1, causes the network to do something different, which causes the sender to have a very different congestion response. And Bob's chart comparing cubic to DC TCP makes that point quite vividly. And then there's the draft, it's got Marcelo's name on it, that generalizes ECN control packets. All 3 of these seem to be reasonable to do experimental RFCs, except that all 3 of them run into language in RFC 3168 and ECN that says you can't do that. And 3168 is standards track. And so the goal here is to write one doc that removes these obstacles. And while we're at it, declare that the ECN nonce experiment is over, and we classify the ECN nonce RFC as historic, as this was an interesting idea. We have moved on from it. I see Brian nodding his head vertically. That's a good sign. Okay, so this draft is intended to be an obstacle clearing draft. One draft to relax the constraints in 3168 and friends that prevent running the experiments. But the relaxation is only to the point of you can write an experimental RFC. It still goes through review here. It still goes through here or TCPM. It still goes through IETF last call. The transport directorate will look at it along the way. The IESG gets looked at it. We're not relaxing degree of control. We're just trying to remove process obstacles, because what was going to happen is everybody was going to write 2 drafts. They were going to write the experimental draft and they wanted to run, and a process draft that said, and the following language in 3168 has to get out of my way. And 3 process drafts was at least too many. So I'm trying to write 1. Okay. For the most part, we're in good shape here. I've been working with the experimenters offline on the list, and we've got, I would say, 95% of the language we think we need in place. Most of it's there. We have one major open issue around ECT1 requirements. I'm going to spend 2 slides talking about what's going on there. And then we got to figure out how to make a decision. And I think Bob and I are going to have a Socratic dialogue about that one. Okay, so ECT1 background. So reminder, ECT1 is one of 2 code points that says this packet is ECN capable. RFC 3168 says you should use the other one, ECT0, if only 1 code point is needed. And the ECN nonce is a counterexample because it used 2 code points. L4S is going to use ECT1 to identify the traffic that will get higher probability CE marking. In essence, go through to go through the low latency queue for L4S, you have to mark CE at a much higher probability than is drop equivalent in order to make all of it work. And now see Bob's math slides for the details. So protocols that use ECT1 to assume drop equivalents are going to have problems, and we have a worked example. The tunnel congestion feedback draft finally got dragged out of where it was stuck, and we realized that this was just going to be a disaster, because tunnel congestion feedback assumes that CE marks are drop equivalent. If you run an L4S queue in the middle of a tunnel and use tunnel congestion feedback, you will be very, very sorry. Well, actually, your classic TCP will be very, very sorry. L4S is successful, IETF may designate ECT1 for L4S only. And now picking up what some of Brian was saying, the ECN nods is the primary known existing use of ECT1. There hasn't been much deployment of it. The RTP RFC, this is 6679, allows ECT1. However, deployment of that is, I think, unclear, very limited at best. And there may be other not yet known existing uses. Okay, 5 minutes in, here comes the money slide. All right, this is proposal. It's not all in the draft, but this is proposed direction. And the goal of the next 20 minutes or so is to figure out how much this is right, how much this is wrong, what to do. I want to walk out of here knowing what I got to do to this draft so we can get so we can get on with this and get on with the experiments. Okay, so here's proposal. ECT0 should be used as otherwise specified by experimental RFC. There will be experimental RFC starting. L4S is going to write the experimental RFC that says here's what ECT1 does. ECT1 should not be used as otherwise specified by experimental RFC. Add text to document the two primary points on the previous slide. Warn that ECT1 used by L4S is likely to result in more network marking of CE than drop equivalents. So if you're going to assume that CE is drop equivalent, ECT1 is not going to do that for you. You probably didn't want to use that. And note that ECT1 might become L4S only in the future, hence use right now. Another RFC, another draft that comes along and says, I want to use ECT1 for this is probably not a good idea. We need to figure out whether L4S works, and they're going to be using ECT1. And finally, Bob found some language in a couple of RFCs that could allow the first two bullets up here, the should and should not, to be dodged if somebody tried to use both code points. I need to write a little more text to take that out. So I believe the fundamental question here is whether in item 1, the should and should not ought to be must and must not. And I think that's the debate. And let me just stop here and ask if there's any questions before we get the debate started. Holy smokes, silence. I must have done something right. Okay. So the draft currently says should and should not. And the reason that I initially put that text in there was 3168 originally used a should to designate ECT0 as a preferred code point. And I wanted to do the minimum I needed to do to enable the experiments. And my belief at the time I wrote the draft was that should and should not were probably sufficient to run the L4S experiment now, especially when coupled with the additional second bullet under 2 that says for now don't write any new RFCs using ECT1. Bob, you want to state the other side of the argument, and then we can go at it?
Bob Briscoe. I've been arguing off list with David for quite some time.
We started the television feedback draft, then moved on to bigger things.
The should that was in RFC 3168 should have been a should.
Ought to have been a should.
Because it was about a choice between two code points, which essentially the hosts could choose, and it didn't make any difference to anyone else which one they chose. Whereas in this case, we've also got an exception in there, because a should implies there's some other exception than the exception here, right? And I think what we're trying to do, or what the IESG would want to do, is say we want these experiments to be under IETF control. And I think that should says you should, or the should not, for instance, on ECT1, let's take that as an example. ECT1 should not be used unless otherwise specified in an experimental RFC. That still means it could be used even if it wasn't specified by an experimental RFC. And I don't think that's what the IASG would want.
My concern, which has been off list, is we've got existing RFCs that do specify that. Somebody might have implemented them. They might be running code. I'm reluctant to use a must to invalidate running code that might exist.
Yeah, I understand that, but we've got a sentence before this saying unless the nonce is implemented, and if there's running code that doesn't implement an RFC, I don't think we have to allow for that. You know, it's not going to take account of our writing anyway because it didn't already. You know.
Okay.
It's just here's 2 bits. Go crazy.
Yeah.
Okay, we should shut up and let other people comment because we've gone about 15 rounds in private email and not resolved it.
If you want to have IESG input, so just having an updating document that makes a change to a previous document doesn't make the document previously invalid in a case like, I mean, if you apply to the previous RFC or you comply to the previous RFC, you still do. Mm-hmm. You don't comply to the new RFC. So your argument about like making existing code invalid doesn't really go for it. You had another argument saying you anyway have to handle those cases, so that doesn't give you much if you put a must in here, but it's not a problem about existing implementations.
That was your 10.
That was my 10, and we're already well into questions, so I'm doing okay up here.
I'm just saying that's not how update works. There's still the old RFC.
Right. The implementation could still claim compliance to the old RFC, but the implementation is no longer compliant with a mandatory requirement in a new RFC. And you can.
Can I ask a clarifying question? Is this a race condition between wanting to make sure that you can use that bit, but not saying what it's for, basically? That if you knew that you were going to set that bit for something now, it would be a must.
If I knew L4S was the answer, and I knew L4S was going to go standards track, I'd put musts up there. And in fact, if L4S is wildly successful, and we discover that one of the ECN ID doc, that draft that Bob previously talked about needs to go standards track, that would absolutely contain must versions of these. So this is mostly a timing issue.
Thank you.
Can I talk now? That was a mistake. Hi, Brian Trammell. So I'll take, I think I'm actually going to take, I've forgotten who's arguing what. I'm going to take my side of the argument.
Thank you.
That if there's going to be a should up there, then you need to give very clear direction as to what are the exceptions. And what I've heard the exception is that I would phrase it like this. ECT0 should be used unless otherwise specified by an experimental RFC. Exceptions include you already implemented this and forgot that you did so. Is that correct? Is that, does that characterize it?
I would put a period before and forgot, but that's certainly,
okay.
That sounds accurate.
Okay. That sounds like a pretty good argument for a must for me.
Okay.
Andrew McGregor, my concern is not actually should versus must. I'm inclined to say it should be must. But an experimental, shouldn't that just be a future RFC?
It actually is a future RFC because you don't need any special permission to write a standards track RFC. It updates things. And the flip side is we wouldn't want an informational RFC to do this.
Fair enough. Okay.
Mia Kuhlmann, and I now have an opinion on this. I would go for a must because with what you do with a should is you basically have 2 code points for the same signal and you say like you can use them interchangeably, but you only need 1 code point actually because it's always the same signal. So just deciding for one, saying that's the one you must use for normal operation is the right thing to do instead of blocking 2 signals for it or potentially blocking 2 signals for it.
Briscoe, I just wanted to come back on the timing thing. I think even if L4S experiment doesn't succeed or whatever, you still need to create the space for the experiment by not allowing other things to use that code point during the experiment. Otherwise, the experiment will fail because other things are using the code point.
I don't think that's a risk, but I haven't heard anybody else who's taking up the should side of the question. So it sounds like I need to go revise this. This slide, pretend that should and should not are must and must not, and that's how we go. That's how we move forward. Does anybody want to disagree with that?
Keeping in mind that we will also have this conversation verified on the list, and
Yes, but I need direction out of the room here, so I can go right the next version of this draft. Okay. All right. So I think the next thing we got to do is, Spencer, you want to do the honors on a hum for adoption of this draft?
Sure. Who's read the draft? So I'm seeing about probably 40% of the room. Would that sound like a good number to you, David, since you're
I
standing
see
up?
about a dozen people who've read it.
Yeah, say 30%. Okay, cool. So we are humming in favor of or waiting, adopting this as a working group draft. So any questions about that? If you would like to see this adopted as a working group draft, which implies that the working group could work on it as a working group, please hum. Please hum. So I'm hearing good, I would say good support in the room for that. Anyone who thinks it is not a good candidate to adopt as a working group draft? The only thing I'm hearing is my timer. So whoever's watching the Jabber Room, is there anybody in there expressing an opinion one way or the other? If not, I will say sense of the room is that this would be adopted. And I will hand the mic and even the chair back to David.
Thank you.
Always a pleasure.
All right, great. Okay. All right. That was the excitement. I think to stay put. All right, that was the excitement. I think what we are now on to, let me just go double check my cheat sheet here, which says, all right, Bob, do you want to say anything about those two drafts? This is ECN and CAP guidelines and what's going to be, I think we talked for the meeting, you're going to retitle this draft to IETF TSVWG RC 6040 shim update or something like that. Yep, the crucial thing is to get the word shim into the draft name. Oh, okay. Right. So I guess the next thing we ought to do is let's also take. So you've seen three L4S drafts. I'm gonna look at the ADs and hope, and if they shoot me a dirty look and I've gotten it wrong. Propose to take an adoption hum on all three of these. Now the process is going to be that we'll take a hum here, but we're going to check adoption of the experimentation draft and list first, and after that's done, we'll check it. We'll check for adoption of the L4S drafts on the list. So how many people have? Okay. How many people have read have read the L4S drafts? Please raise your hands. Yeah, about the same as last time. Maybe 8, maybe 6 or 8. I think we'll go ahead and take one hum on all three of them. Anybody who thinks we should not take a combined hum on all three of them should go to a mic, please. Let's figure that offline on the charter. We want. So Mir asked you add something to the charter. Well, obviously at some point we'll have to add we'll at least have to add goals and milestones. TSVWG has a broad charter. We're allowed to do anything in the transport area. L4S is clearly in the transport areas. I don't think we need to get the IESG to change our scope, but we will add milestones for when we think they'll be done. Good enough? Okay. All right. So hum if you think that the working group should adopt the 3 L4S drafts you saw earlier. All right. I hear reasonably broad support for them. How many of you think that the draft should not be adopted and TSUWG should not work on L4S? And I hear silence, except that Spencer's phone may have a second opinion. Okay, and thanks for the reminder, because I almost skipped that. Okay, Bob, what do you want to say about the ECN and CAP draft and what's going to become the shim update to RFC 6040?
Yeah, apologies for not doing slides, but
You were kind of busy making sure the previous stuff just happened.
Yeah. And also the ECN NCAP draft, I must admit, I thought it was all finished. And it's just like, we've got a final liaison statement to send off, which I thought was David's fault, but I just apologized to him yesterday because I had thought I'd replied to him to say, yes, go ahead, send the liaison, but I didn't press click. That once that liaison has gone off, we're finished, really. There was nothing else to write into the draft than what I wrote in it due to the liaison. So there's, the draft, I guess maybe you need a final review of it by someone, but otherwise it's had a few reviews.
Okay, so process from here is send the liaison and then send the draft working group last call. Probably can't get to working group last call until sometime after the first of the year, as we've got a few more drafts in teed up working group last call before then, but that's fine.
Okay.
With luck, we'll have it through working group last call and perhaps going someplace other than this working group by Chicago.
Yeah. Okay, so the RFC 6040 update shim, which it's going to be called in a few seconds when I upload it, which was called RFC 6040 BIS wrongly, is a very brief thing saying the scope of RFC 6040 included IP in IP with a shim in between, not just IP and IP. That's virtually all it says, but that allows it to be a PS that updates a number of other shim PSs, whereas the ECN NCAP draft is a BCP, so it can't update PSs without a process exception.
We're going to have to work the process on that one carefully, because every time we touch somebody else's RFC, they usually care.
Yeah.
The rest of what Bob was going to say is that the whole bit about 6040 and why this much attention being paid is that 6040 contains an algorithm. It says a tunnel egress where you've got ECN markings in both the inner and outer headers. Here is exactly what you do, and the shim update basically says and still do it even if there were a few more headers between the inner and outer IP headers.
I don't think anyone is going to object to this touching their RFC because largely they've already done it. There will be worries about prior implementations and things, but obviously being an update, that's like anything that's updated, it doesn't have to apply to prior implementations. I don't foresee any problems, but obviously, people get proprietorial about their RFCs.
Right. And anytime you put an RFC number in the updates header, it behooves us to check with folks who work on that stuff.
Yeah, and in particular, where things haven't been implemented because they're like old stuff on GRE or something like that, where ECN wasn't done properly, it could create quite a bit of extra work for someone to do an update to the code. So in particular, because ECN is a bit more difficult than any of the other parts of the tunneling code, right? Because you have to compare the inner and the outer.
Okay, so by the way, this was adopted as working group draft. It just hasn't gotten uploaded with the working group name yet. So yeah, we don't have another adoption call to run. That's
correct. So that's it really.
Okay, good enough.
Yep.
All right, let me go clean up a bunch of windows here, and then I think Jake, you're next. Yes, indeed you are. Let me go see if I can get this thing to cough up your slides. Hang on a minute. There it goes. All right. It probably has on my screen multiple times. And here's the magic slide clicker if you want it.
Oh, yeah, great. Thank you.
You see, red button near the front. We even give you a laser pointer.
Excellent. Thank you. All right, I'm Jake Holland, and I'm talking about a congestion control problem in multicast that I would very much like to have solved. So the basic problem is that senders send inherently in multicast non-responsive data to anyone who is not sending feedback, which in the case of receiver-driven congestion control is all of the receivers, and in the case of sender feedback-based congestion control is any receivers who are not actively sending feedback. So the problem then is that although there are some very interesting multicast congestion control protocols, any receiver which becomes compromised and doesn't participate and instead joins all the flows that he can, or all the flows with the highest bandwidth, or whatever it is, can easily induce excessive joining of the flows and excessive traffic through the shared network links and cause a denial of service against all the other receivers in the network. The solution I'll be talking about in ICCRG is an attempt to implement a circuit breaker that addresses this problem. And ultimately, of course, I would like to bring it to the transport group and move it down the standards track. If you did manage to read the draft, then thank you, and I apologize for its raw newness. But it's very much along the lines of the strategy described in the circuit breaker draft for the transport group. The basic idea is that the senders will send bandwidth advertisements as part of their as part of the data stream. The intermediate routers will notice these bandwidth advertisements and detect that their links are oversubscribed when they are. It has a few problems called out in the draft about, it shares some issues with the router alert option but the intent then is to notice and prune or block the most problematic flows. When possible, adding, noticing that when available, there's an experimental PIM extension which provides a population count, which can make for more fair choices on which specific flows to block under high congestion. So please come to ICCRG. Please review and help me get this solved. The reason that I'm here is I would like to run, a service that transmits thousands of video channels, and we thought AMT was our last big problem. Until we could have organic growth, all we have to do is convince ISPs to sign up, right? Which is non-trivial, but you can do it one at a time. However, we don't think we can scale it the way we'd like to scale it until we have a solution to this problem. Thank you.
Yeah. So anybody interested, please follow with Jake. This is definitely innovative, because the circuit breaker draft, I think, was originally written anticipating that the circuit breaker would likely be located endpoints, and here the plan is to put it in the network, in the routers that understand what the multicast flows are doing.
Right, and I just want to point out that, yeah, that's a great point, and the main reason for doing that is that you can't always trust the endpoints to do the right thing, and the network has to have some participation in ensuring its safety in this situation, I think. And it needs to be a standard because it needs to interoperate between domains, is the basic position I came up with. It's the only problem that we found that I couldn't solve no matter how hard I work at it.
Any comments?
Tim Chan. So I think there's some good points raised in either MBOND or PIM, wherever you
MBOND, yeah.
prepared it. Sorry, jet lag. Presented it yesterday. Got the word eventually. So I think there are some questions like whether or not the clients can adapt themselves. A few other comments about. I think I made a comment about
whether this would just be targeted at a single domain or whether it's optimistic to get it internet wide. I think these are good questions, and it'll be interesting to see how it goes forward. But in general, the idea is pretty interesting, I think.
Thank you.
Cool. More to come in ICCRG. Thank you very much. Okay. Yolanda? Yes. All right.
Hello, everyone. I'm Yolanda Yu from Huawei. So today I want to introduce a mechanism about a layer 3 QCN. So as we know, in IEEE 82001 QAU specification, the QCN mechanism is designed, and I think QCN is a very good mechanism because it directly reflects the congestion status of the network, and I think it is an efficient mechanism to reduce the congestion status or congestion possibility in the network. So our team think if we could extend the QCN mechanism to layer 3 network, because as we know, the QCN is designed only in the layer 2 network. So we called the L3 QCN. So I raised this draft in October, so it's only in 00 vision. Thank you. And at first, I think the L3 QCN is only used in a very simple scenario. It's only on a very simple network hierarchies. So I read that draft, but David and Pat suggest that if we could consider that level 3 QCN could be used in a more complex scenario, such as tunneling or nested tunneling or different network topologies. So in my draft, I only list a very simple scenarios like this slides. So we sorry. Okay. So it is a very simple example. For example, host 2 send out the streams through TOR2 and then arrive TOR4. And we found that at between TOR4 and host 4, there is a congestion. So then we will construct a private connection notification message to go through the IP network and then to go back to TOR2. Then TOR2 will translate or transfer the private connection notification message to a standard CNM. Then they will use the standard QCN mechanism within the layer 2 domain. So that's our mindset. So the goal of layer 3 QCN is just to extend the QCN mechanism in the IP network so that we could transfer the QCN message through the layer 3 network. That's our mindset.
Okay.
Any comment or question?
Okay.
Yeah.
Do you have any more slides, or is that it? Okay. You had you have one more slide if you want to present it.
Do you want to finish? Or-
Yeah, one more slide, just our next plan about the this draft because in this version we only consider a very simple scenario. The network hierarchy is quite simple, so we'll think about more generic scenarios, including the tunneling or nested tunneling.
Okay, so I'm Bob Briscoe. My question is, when you say in a layer 3 network, do you mean any layer 3 network, or is it still in a controlled environment, but it's just multiple layer 2 networks connected together? In other words, have you still got a sort of single control and also maybe less security concerns and things like that, or are you talking about the general internet?
We're thinking about the generic scenario, including all the possible,
Okay.
I mean, topologies or.
Because it sounds like, I mean, there's a lot to QCN, but it sounds like the main thing you want to do is have the backward feedback messages.
Yeah.
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 Because obviously QCN is a PI controller, proportional intercontroller. We've already got pi, you know, and so a pi AQM is effectively doing what QCN does, and the only real difference is that in layer 3 the message goes forwards to the receiver and then back to the sender, and you're trying to go directly backwards. Yeah.
No, I will. At first, I will construct the private, the CNM, and then we will translate. I mean, I do not. I need to transfer in the layer 3.
Yeah. So you're saying you're going to construct a no.
Yeah. I construct. CNM congestion notification, but it's similar to the standard CNM.
Yes. Okay. So all the arguments against backward congestion notification apply here, which is why they aren't used in layer 3 networks, and that is they're very difficult to authenticate because the sender doesn't know that it was meant to be talking over a certain router. It was trying to talk to the other end.
Yeah.
And so a message that's coming from something in the middle that says, I'm router number 742, you say, yeah, okay. Even though you're authentically router 742, I didn't know I was meant to be talking to router 742 anyway. So it's a message coming from someone, and therefore someone else, you know, can say, I'm router 742 and DOS you by saying, slow down. Do you see what I mean?
Yeah, I understand.
And then there's all the problems as you mentioned of tunnels and going backwards through tunnels, which is why in layer 3 networks, doing the congestion notification forwards and propagating back up binds you within the security of a transport layer session. So sessions can't be hijacked, and all that's sorted out in TCP and UDP and things. So the feedback goes back at layer 4, and it's much more difficult to inject
yes,
into that.
Yes.
Yeah. So it's a security issue primarily.
Yeah.
David Black, standing at the floor mic, because it's individual comments. So I'm going to take the other side of the coin from Bob, which is, I think Bob's got a point about full generality, but I looked at this draft and said, it's almost certainly applicable to more topologies than what is shown here. And the one that immediately came to mind was L3 VPN, in which a lot of the concerns that Bob has about origin authentication can be dealt with in provisioning and administering the VPN service and the data centers that you use it to connect in that scenario. So, okay, well, I believe it's going to be generalized, and I think Bob's raised a bunch of interesting points that need to be considered, but there are certainly structures like L3 VPN that it would be, in my opinion, would be reasonable to think about as applying to in addition to data center leaf spine networks.
Okay, thank you.
Yeah, so
Pat, you need to say who you are.
Pat, sorry,
You don't know
yes.
who you are.
Pat Thaler, Broadcom, and also IEEE 802 Vice Chair and Chair of the Data Center Bridging Group, which produced 802.1 QAU. the problem is that we're doing too many. Well, one of the problems is we're doing all sorts of tunnels, and basically the attraction of backwards congestion notification is to make the control loop a little bit shorter, to make the reaction a little bit faster, so you're not delayed in getting the congestion notification. And that's why we chose BCN when we did QAU. But we didn't foresee that people would do all these crazy tunnels. And
see Ross
layer
Cowan's
2
talk
and
at the
layer
last
3
plenary.
and et cetera. And so there's the ECN NCAP draft out there, and about kind of what you want to do with congestion notification and what you want to do to make sure congestion notification can survive networks with all these tunnels. And so much as I loved it at the time, I really have doubts about the utility of a backwards congestion notification in the kind of networks we're making today, and whether it's going to be able to get to the source. And so I think that's really the question that needs to be answered. Is well, one of the questions anyway is whether it's worth trying to do that, or whether we should just stick with forward congestion notifications. And yeah, then we're kind of stuck with the fact that it's 1 bit and we don't get the quantitative feedback, which was nice. One message could tell you not only was it congested, but something about how congested it was. And that was a nice feature, and I wish we had more bits to forward congestion notify with, but I don't think we can do much about that right now. But
Thank you, Pat.
Blue sheets. Who's got the blue sheets? Okay, thank you, Yolanda. All right, come on. I need blue sheets. Okay, we got both clipboards back there. We do indeed. Thank you. Secretariat, in addition to reminding you to stay in the pink box, has a standing offer to schedule any working group that fails to turn in blue sheets to meet in a closet at the next IETF. All right, I think we're done. Thank you very much, everybody. And both Yolanda's draft and Jake's draft will be, I believe, are on the ICCRG agenda in the next time slot. All righty. Thanks for coming to list your drafts.
I was gonna send an email to the TCPM shows about
which?
About the should I wait a little bit, or is it like when is the right time to?
They could go ahead and adopt now. There should be no problem. I had a private question from Michael Sharp about when to adopt, and I said, go ahead. But I said, there's no reason to wait, particularly with it now being pretty clear that it can be adopted. We will be confirming the ECN implementation adoption mailing list. It's quite likely the mailing list is going to say yes, and it would be okay for I don't see a problem with TCPM adopting both of the ECN files over there. No, don't. It hasn't been adopted. Even common sense from the room is that the sense room is to adopt. It's got to be confirmed in the mailing list. Within a week or two, we'll know. And the expected answer is yes. All right.
Okay. Thank you.
Okay. All right.
yeah.
Quite
Holy smokes, under 25.
That was that was already a given. But I
About 35 on that sheet. So the magic number is about 65. So not bad. There, the sheet's going to be once then.
The next step is that our MCAT solid rock.
Go to ICCRG.